Hello everyone. For fourth semester, I am going to engage classes on interference. Okay, now let us see syllabus of interference. Interference is totally 18-hour topic, and here we have two subtopics. The first one is interference due to division of wavefront, and the second one is interference due to division of amplitude. In first concept, that is interference due to division of wavefront, we are going to study Fresnel's biprism, determination of wavelength of monochromatic light, and thickness of a thin film using biprism. In second concept, that is interference due to division of amplitude. Here we are going to study Stokes treatment of reflection and transmission at an interface, and thin films, condition for maxima and minima in case of reflected light, derivation, multiple reflection, and mention of condition for maxima and minima in case of transmitted light, then exhibition of colors by thin films, then qualitative discussion of wedge shaped film with mention of expression for path difference, then theory of Newton's ring and determination of wavelength of monochromatic light using Newton's rings, then Michelson interferometer, formulation of circular and straight fringes, qualitative explanation, then determination of wavelength of monochromatic light using Michelson interferometer, then standardization of meter. This is totally 15 hours topic, and last one is problems for 3 hours. Okay, before going to start interference, let us discuss some of the basic concepts, that is the basic structure of a wave, then the visible spectrum, and then what is coherent sources. After studying these three concepts, let us move to the interference. Let us discuss general structure of wave. Here I am going to draw a basic structure of wave. This is the wave structure, and this is the direction of wave. Direction of wave, and this top point we call it as a crest, and this bottom point we call it as a trough, and the distance between two crests, we call this distance as a wavelength, and the distance between midline and crest point, we call this region as a amplitude. This is the basic structure of wave. Okay, now let us see the visible light spectrum. We all know that the visible light spectrum consists of different colors. That is, first one is red, then orange, then yellow, after that green, then blue, then indigo, after that violet. This is the visible spectrum region, and we know that the violet is having 400 nanometer wavelength and the red one is having 700 nanometer. That is, if you represent this in wave structure, then the red one is having longer wavelength as compared to the violet one. The red one is having longer wavelength and violet one is having a shorter wavelength. Okay, now let us see what is coherent source. Here, let us suppose if there is a source and from this source waves are emitting. Here, if all the waves have the exactly same frequency and there is zero phase difference between these waves, then we call such source as a coherent sources. If the source which is having same frequency and they have zero phase difference or constant phase difference, then such source we call it as a coherent source.